All right, so step 1 was to state our hypothesis on this t-test. Step 2 was calculate the t-statistic, which is found with the t-CDF, or not, the t-statistic x bar minus mu s over the square root of n. And when we do that on our calculator, we should come up with negative 4.47. Step 3 is to find the p-value. And the p-value, like we've done on the previous hypothesis test, is the probability that we can get a sample with a mean of 2.5 or smaller if the population really has a mean of 2.8. So our p-value here is that we're going to look at the probability of that. We want to know, well, I got this sample of 2.5. Is that just random sampling variation, the difference between the 2.5 and the 2.8? Is that just random sampling variation? Or is that far enough away that I can say it's very improbable that I could get a sample with a mean of 2.5 if the population really has a mean of 2.8? So we're going to calculate with our p-value, and we're going to do that on our calculator. We're going to use the tCDF function. And what we need is we need a lower bound, an upper bound, and the degrees of freedom. You need to feed it 3 different numbers. Our lower bound here, we're looking at a less than alternative hypothesis. So we're anticipating our sampling distribution is going to look something like this. We've got a mean of 2.8. What we're trying to do is find what's the probability that I can get 2.5 or less. So our lower bound on our interval where we're trying to find this area is going to be a negative infinity is what we want to do, but I want to use a really large negative number in there. And then I'm going to use my t-score, so I want to go up to negative 4.47 with degrees of freedom. Degrees of freedom is 1 less than your sample size. So I had a sample size of 20, so my sample size should be 19 for this problem, or my degrees of freedom should be 19 for this degrees of freedom. So that's what I want to do. Let's enter it into our calculator. So let me hop over to my calculator here. There's our calculator, and there was the t-value we just calculated. You can find the tCDF under the distributions here, up above the variables. It's a second function. I got to use the second to get there. Second function distribution. And there it is. It's the 6th option down, tCDF. And I need to go from negative infinity. And so I just like to put in a negative with a bunch of 9s. Again, there's more area in the curve on the t distribution out in that left-hand tail. So you want to make sure your infinity is bigger so that you're using a bigger number there. And let's just round this off to negative 4.47. Whoops, I got an extra negative sign in there. Or do you want to be really accurate? We can type in negative 4.47, but if we want to be really accurate, or the easy way is to do second, and then right above the negative key is this answer. And it will use your previous answer, whatever value you got. My previous calculation was the z-score, so I'm going to use that previous answer. And then I need a comma, and then the degrees of freedom, and I have 19 degrees of freedom. And a lot of students I see get errors doing this because they're forgetting to put in the degrees of freedom. That's a very common sort of thing. So we're going to type all that in, hit the enter key, and get our p-value. So I'm going to go ahead and do that. Error syntax. What did I do this time? Let's go to that syntax. Oh, I got 2 commas in there. That's the problem. We'll get wrapped around between the 2 ends. Let's delete one. There's the delete key. And then hit enter. Now it works out. All right, so what's happened here, it's saying that your p-value is 1.3. Well, your p-value can't really be 1.3, but if you look over here to the right, you've got this e to the minus 4 over here. What's happened is our calculator has shifted into scientific notation. So I've got 1.3059, or 1.306 times 10 to the minus 4 is what that means. So let me switch back to my OneNote here. I'm getting a p-value of 1.3 0.306 times 10 to the minus 4 power. And so to write that as a regular number, what I need to do is I need to shift that decimal place 4 places to the left. So it would be 0.001306 as our p-value. All right, so enter that in down below and move on to the next question, which should ask us about our conclusion.